Hello everyone, my name is Nikta Mishra. I am from Electronics and Instrumentation Department. I will be briefing you on gesture control robo. My team members include Madhul Mayank, Reema Raj and Riya Saini. Robots are playing an important role in automation across all the sectors like construction, military, medical, manufacturing, etc. After making some basic robots like line follower robo, computer controlled robo, etc., we have developed this accelerometer based gesture controlled robo by using Arduino. In this project, we have used hand motion to drive the robo. For this purpose, we have used accelerometer which works on acceleration. The gesture movement is done with the help of 3-axis accelerometer ADXL335. It works based on tilting the accelerometer in various directions. Based on the accelerometer directions, the robo is controlled. The accelerometer is placed on the hand that is used to transmit the signal that is configured with Arduino. And the controlling of the motor is done with NI MyRio using LabVIEW. Based on the transmitting device value, the robo movement is controlled in various directions like forward, backward, left, right and stop. The movement indication is viewed in this figure as you all can see. Motivation. So what really prompted us in choosing this topic? In few years, robots are going to degrade the cosmos. Man supremacy is abridged by replacing robots. In the existing system, human hand movements is sensed by the robo through sensors and it imitates the same. This is made probable by placing the sensor in the accelerometer, which is to be carried by the person user's hand. As the person moves his or her hand, the accelerometer also moves accordingly, which in turn displaces the sensor, and this sensor senses the constraints according to the position of the hand. And these sensed constraints are given to the sensors placed in the robotic arm, which makes the movements of the robo arm accordingly. Hand gestures and even in fact body posture plays a very vital role in human communication.
So in order to find inspiration and motivation for our project, we looked through various scientific papers which were published in journals and we could access them online. The first paper that we came across was Gesture Controlled Robot by interfacing LabVIEW and Arduino. In this project, they used an accelerometer to transmit the hand movements to the software for processing and moving the robot. So the advantage of this process was that the hand gestures and movements were very accurately and efficiently read. However, supplying a constant power supply was a tough task, and there were other hardware related issues also. Next paper was gesture control of robotic arm. So in this method, the user could give the commands to the software through webcam, and the system was interfaced directly. So the advantage was that the robotic arm could be used in hazardous environments and the user need not be present in those environments. So the scope of this model was wide. The disadvantage, however, was that if the distance was greater than 1.5 meter between the user and the camera, the algorithm could not properly work. It was not very efficient. The next was gesture controlled robot using LabVIEW. This was also a similar model in which the gesture could be transmitted using a webcam. However, the difference between this and the previous one was that this robot was interfaced through a MyRio device. So the data was acquired through MyRio and then transmitted for further processing to the LabVIEW software. The cost of such a prototype was higher compared to the previous one because of the use of MyRio. The last paper was LabVIEW controlled robot for object handling using NMIRIO. In this, the model of the robot was equipped with an RFID and IR sensor. So the model was capable of navigating on its own because it could detect obstacles using IR sensor. And for this method, the code of the object, there was a barcode kind of system which was already fed into the model of the robot, and the model of the robot then could scan the barcode on the objects to see if it matches the code already fed into it, and then select the select the object accordingly. The disadvantage was that it had to check each and every object to check whether it was the desired object or not, which took a lot of time. The object could not be directly directed towards the desired object.
Hello everyone, my name is Madhulman and I'm going to explain you about the methodology, i.e. the working of the instrument. So we are going to use three components. So going on to the first one, which is going to be a Arduino Uno board. So as we all know that Arduino is a 28-pin microcontroller. In this circuit, it's going to act as a transmitter. The second component which we are going to use is NI Myrio, NI being the name of the manufacturer, which is National Instrument, and the other part Myrio, which means My Reconfigurable Input and Output. So Myrio has three ports, namely A, B and C. AB constitutes of total of 64 pins, which is Myrio expansion port. Port C, which basically resembles that of NI MyDAC, it consists of 8 digital input output pins and 4 analog input output pins. A0 and A1 are majorly used for wireless networking with a frequency range of 2.4 GHz to 2.5 GHz. So moving on to the diagram of Myrio. This third number cable is used to power the Myrio. The fourth number and the fifth number are used to transfer the data from the computer to the Myrio. 7 number are used to connect the connector pins. The 8 number are the audio cables that are connected into the audio jacks for input and output. 9 number is the pin, and the second one is Myrio expansion port. The third instrument which we are going to use is an accelerometer. As we all know that Myrio already has an accelerometer, but here we will be using Myrio only for some smooth data connectivity basically. So moving on to the type of accelerometer which we'll be using is ADXL335. It's also a 3-axis accelerometer with 3 axes named as X, Y and Z, and represented by X out, Y out and Z out. It has a full scale range of 3G. So moving on to the specification, it has a low power consumption of 350 microampere, supply voltage of 1.8 volts to 3.3 volts, 3 axes namely X, Y and Z. Based upon these axes, the accelerometer is calibrated with the use of Arduino. Because of these 3 axes, the robot movement is controlled. For example, if the robot is stop condition, X-axis value is considered. Similarly, for the other directions like forward, reverse, left, right, consider any of the other axes. So the software which we are going to use obviously will consist of Arduino's software, as the basic coding is going to be done on that software, and Arduino is also going to act as a transmitter over here. So we can see the pin configuration of the Arduino over here, with VCC going to 3.3 volt, ground going to the ground pin as usual, and X out, Y out and Z out taking the pins A0, A1 and A2. The other basic software, the most important one which we'll be using is NI LabVIEW. Using the virtual instrumentation package manager, we are going to interface the Arduino with LabVIEW, and we are going to dump the code into the Arduino using this software. Here Myrio is configured with wireless with the help of NI Max because it is useful for surveillance purpose. After configuring it with wireless network, connect Myrio with that wireless network. In case the wireless network name is gesture, after connecting it, we can communicate much better. The VI package manager, which is basically going to help us to interface the Arduino and the LabVIEW programming version. So this is the VI package managers, which has the add-ons as follows. The LabVIEW implementation, as we all know that it has a front panel and a block diagram part. Block diagram is a part where the main coding logic and the skill set of the programmer is utilized, and the representation is given in the front panel. So this is the basic block diagram of the gesture control robot which we are going to make, which consists of Arduino, which is going to be interfaced with LabVIEW, and it's going to get the data from the LabVIEW itself, and it's going to transmit the data to the motor driver, and the motor driver is going to consist of the left motor and the right motor. So LabVIEW is the software. The program in the software is going to decide which motor should be working, left or the right one, and it's going to display it on the front panel. Using our IR camera, we can record the gestures and thus displaying it and using it simultaneously and matching it with the registered ones. The LabVIEW recognizes the gesture and sends the required signal to the Arduino, which is furthermore sent to the motor driver for the movement of the motor.
Hello everybody, this is Reema Raj, and now I'm going to discuss various applications of accelerometer based gesture robots. So firstly, it's automated homes. As we know, we can control various appliances in our homes with respect to our hand gesture and through robots. So by moving our hand, we can control the robots which can handle the various applications and appliances in our home, and thus we can say that it's an automated home. Driving to safety, it's very efficient and better that a robot drives a system or a car, and this can also be beneficial for people who are not comfortable in driving, and also it helps in preventing accidents that occur. And gesture for work, this is suitable for people who spend half their life making presentations and half their life presenting it, and it's also suitable for gamers who want more physical oriented games so that they can control their game cartoons with their hands and stuff, so they can be more invested in their games, so it helps in that purpose too. Moving on. Construction applications. So robot can be used instead of people for carrying various heavy loads in demolishing purpose and constructing purpose, carrying weighted objects from here to there. It prevents accidents which happen to people in construction sites, and it helps in doing work in lesser amount of time. Military applications, war robots can be made which can be controlled by people, which will help in preventing the loss of soldiers. The medical application like surgery and various hospital-oriented works can be done by robots which can carry out operations with more efficiency and more success rate. And then for gaming purpose, it can be very interactive. Okay, the expected results, this is related to the outcome. For example, if we want our robots to move in forward direction, then we can move our hand which contains accelerometer in forward direction. So we have various booleans for various directions. For example, for stop we have all zeros, for forward we have 1 0 1 1, for backward we have 0 1 1 and left 1 0 1 0 and right 1 0 0 1. This is the simulation which we get after dropping the code in LabVIEW, which is interfaced with Arduino. These are the various references which we have referred to in making our self-study, which is gesture control robot by interfacing LabVIEW and Arduino, gesture control of robotic arm, gesture controlled robot using LabVIEW, LabVIEW controlled robot for object handling using MyRio. These are our main subjects in which we are our self studies related to. First is VI, that is virtual instrumentation using LabVIEW. The program which we are using is written in graphical level VI programming language using LabVIEW. Also the modules used in like MyRio have code dumped in VI. And APC, that is automatic process control and modeling technique, controlling the robot and its movement and restricting them to be performed within a stipulated area. And also relates to CCN and Java. The programming skill set and the logic required to write a Java program are being used to write The VI and also the receiver and the transmitter constitute the digital communication part. So we are contributing to both the subjects in this way. So thank you. This was our self study.